Hey everyone, I'm back with another problem on the InterviewBit series for the topic arrays. So the problem is called large factorials. The problem description is quite simple. So we are given a number and we just need to find the factorial of this number. But the point here to note is that the constraints, the number can range up to 100. So the max we can go is up till 100 factorial, right? And just as a matter of fact, 100 factorial can have 158 digits. That's too much. That's too much, right? Also you'd think that this is a pretty straightforward multiplication problem where we could just multiply all the numbers from 1 till n and let's go. There's our answer, but no. When you multiply or when you take the factorial of 100, it has 158 digits. So here we are just having a variable to store the factorials. But can any data type store 158 digits? It's quite not quite possible because it would give an overflow error. Just as a matter of fact, even the long which we have in C++ only supports up to 18 to 19 digits, which is so less as compared to 158 for 100. So we need an entirely different approach for this problem, right? So the idea here is, since we cannot have this entire factorial or a large number stored in a single variable, but can we store its digit in an array? Can we store its digit in an array format? Yes, we can. Right. So even the 100 factorial has 158 digits. So I can store all its digits inside an array. Right. So instead of factorial variable, I'll maintain a factorial array where I'll be storing the digits of the factorial. I'll be calculating at each and every step. Right. Perfect. Okay. Okay, how do we now approach this problem? Let's just take for example, we have n is equals to 4, right? So we are given the condition to us given to us is a is less than or equal to 100. So we can have at most up to 158 digits. So let's just assume we have a long array of length 200. Since we have 158 max, but let's for safety we'll take 200. We'll we'll just assign an array of size 200 at the top. Okay, now let's assume we have a 4 factorial and we need to calculate 4 factorial, right? Okay, perfect. So let's assume we have a very long array. It ends up to 200. It can store up to 200 digits. Perfect. So the first thing what I need to do here is I need to get 1 into 2 into 3 into 4, right? So what is one factor? What is one factorial? It is 1. So I'll just store 1 in the factorial array as 1 because this is the base case, right? 1 multiplied by 1 is 1. Perfect. Now what I need to get, what is my factorial array currently storing? This is 1. Now I need to multiply 1 with this 2. All right, so how will I do that? What is the current size of the array? I need to keep a track of that as well, right? What is my size of the factorial array? It's 1 for now. So I need to track that as well. Then only I'll able to iterate it in the factorial array and I'll multiply 2 to that number. Perfect. So now it is 1. So I'll try to multiply 1 with 2. Okay. So the factorial represents 1 and I'll multiply it with 2. So I get 2. Great. So now I'll replace it with 2. What is the size? The size still remains the same, which is 1. Okay. Now let's move forward. Now we need to multiply our factorial array with 3. Okay. So what are we currently storing? We have 2 and we need to multiply it with 3. So what do we get? We get 6, right? So we'll replace it here. What is the size? The size still remains 1, right? Now let's move forward. Now we have 4 and our factorial array stores 6. We need to multiply 6 with 4. So what do we get? We get 24. Now here is an interesting part. Now we have 24. So how do we store 24 here? So we'll store it in a reverse fashion. Because why do we store it in a reverse fashion? Because that would help us multiply in an easier way. When we multiply in the reverse fashion, we just tend to move the carry forward and we just add it and then continue. Okay, that's why we store the factorial in a reverse fashion, and at the end when we have the answer, we'll just reverse it and we'll just print the answer. Okay, so for 24, how will you store that? How will you get the last digit of 24? Easy. What we'll do is 24 mod 10, which is 4. Okay, now you also need to maintain a variable called carry. Okay, what is the carry after storing 4? The carry becomes 2. Okay, the carry becomes 2. Now since we do not have any number, we'll just place the carry over here. Okay, that's it. And also we'll update the size. The size now becomes 2. Perfect. Now we'll iterate from size minus 1, which is the index 1, and we'll try to add this to our string. So the answer becomes 24, which is 4 factorial. Great. Now let's take another example. Now let's take the case of 6 factorial here, right? So for 6, we have 1 into 2 into 3, 4, 5, and 6. Assume again we have a very long array which ends up till here. Its size is 200. We'll store 1. So we'll keep track of two variables, which is size. Currently it's 1 and carry. The carry is 0 for now, right? So until 3, I do not need any carry and my size still remains 1, right? So 1 into 1 is 1, 2 into 1 is 2, 3 into 2 is 6. So I'll just directly write 6 here. Now we are done till here. Now coming on to 24 factorial, right, which is 24. So we also have, we'll just store 24 over here, which is 4 and 2. Okay, the carry is 0 for now. So we are done up till this part. Perfect. Now I'll try to multiply 5 with 24. Now how do you do that? So in order to multiply 5 with 24, what you do is first you multiply 5 with 4. Okay, so what is 5 into 4? 5 into 4 is 20. So what do? You will take the last digit of 20 and you'll place it here. Okay, last digit of 20, place it here. The carry becomes 2. Okay, the carry becomes 2. Now you will try to multiply 5 with 2, which is 5 into 2, which is 10. Plus you'll add the carry, right, which is 12. Perfect. Now you'll take the last digit of 12, which is 2. You'll place it here. Great. Now the carry becomes 1. Now we do not have any number left in the factorial, but we do have a carry. So we'll update the carry. Okay. So this becomes 1. Perfect. Now the size becomes 3 here and the values are 1, 2, 0. So I'll update it. I'll update it in my factorial array, which is 1, 2, 0. Perfect. Perfect. Got it. Okay. Now we are done up till this part. Now how do we multiply 6 with 120? Same process. Same process, guys. So what we'll do is, so let's just first assign it to, the size is 3. Perfect. The carry is 0. Now let's move on. What is 6 into 0? 6 into 0 is 0 plus carry. We do not have a carry, so it's 0 only, right? We'll mark 0 here. Perfect. Let's move on. What is 6 into 2? 6 into 2 is 12. So we'll take the last digit and we'll store it here, which is 2. We'll store it here. What is carry? Carry becomes 1, whatever is left. Perfect. Now we'll multiply 6 with 1, which is 6 only. And plus there is a carry. There is a carry. So we'll add it to the answer, which is 7. Right? So we'll remove 1, we'll store 7. Okay, and the carry becomes 0. The size also becomes 3. Okay, so now we have a final answer with us, which is 6 factorial is equals to 720. Perfect. So this is the approach we are going to use. We won't store the factorial in a single variable. It's because it has a large number of digits and it is not possible to fit that large number inside a single variable, right? So we'll play smart here and we'll try to store that large number and its digits in form of an array, and we'll use the basic multiplication and we'll update as we move accordingly. So what is the time complexity of this approach? What is the time complexity of this approach? First of all, we'll have n because we are iterating from 1 to n, right? And we are multiplying every digit. And also it's going to be log of n factorial. Why there would be a log of n factorial? Because we are also multiplying and adding with its digit, right? For every number we are multiplying with its digit, hence the log n factorial comes into picture. And what is the space complexity? The space complexity is O of, we have used an external array of size 200, which you can say it as a constant time. Okay, perfect. Okay, now let's move on to the coding part. Okay, now let's code it up real quick. So we are given this number and we have to return a string format of the factorial of a. Right, so the first thing which we are going to do is we are going to prepare the factorial array, vector and factorial. So 100 factorial can have at most 158 digits, but let's, for the safe side, let's consider it to be 200, right? And what would be the base case? Factorial at index 0 is going to be 1, because 1 into any number is 1, right? Perfect. And what is the size? So currently the size of my factorial array, or the number of digits I've used inside the factorial array, is 1. All right. Now I'll iterate for the numbers starting from 2 and we'll go up till a, I plus plus. We'll create a function called multiply, which multiplies this number and takes in the argument I. Okay, perfect. Let's create this function multiply. So it takes the current number which we need to multiply, it takes the factorial, and also it takes the size of the factorial, right? So pass I to it, pass the factorial, pass the size. And now let's just try to write the multiply function. So how do we actually multiply it inside the array, right? So the first thing which we are going to define is the carry. Okay, so the carry initially will remain 0. Now we know the size of the array, so we'll iterate from 0 till the size of the factorial array and we'll try to multiply it. So the product is going to be nothing but the number which we want to multiply into the factorial at index I. Okay, plus don't forget the carry. Okay, now what are we going to put? We'll put the last digit of the product inside the factorial at index I. Okay, and we can access it by having product mod 10, right? And product is and then you can update carry is equals to product divided by 10. Perfect. So this will try to assign the last digits of every product we calculate along the way. Now at the end we would be having some carry remaining with us. So we'll iterate till the carry is not 0, and we'll try to assign, which is factorial of size is equals to carry mod 10. So we'll also try to place the last digits first from the carry itself. Okay, and carry is equals to carry divided by 10. Also, one thing is you'll increase the size when you try to place any new element in the factorial array, right? Perfect. So this will fill the factorial array, and now we have a fully filled factorial array. We know its size, so let's just create a string called answer. Here we'll try to store our answer, and we'll start from size -1. So we'll go till the 0th index and answer plus toString. Since it's an integer, we need to convert it into a string, and here is the function which converts it into a string, and we'll say factorial of I. Perfect. At the end we return the answer. Let's try to run it. Okay, there's some typo here. Okay, why? Okay, we'll submit once again. So the trivial cases are passed. We'll submit. Perfect. So it's accepted. So this was a really nice problem. Yeah, the only thing which we needed to do was how do you store a large number inside an array. So we did it using their digits, right? So this was a nice problem. I hope you guys understood it. Okay, we'll meet in the next video. Till then, take care. Okay, chalo, bye.